Can we have class on
Yes,
Wednesday
sir. Yes, sir.
around 12 p.m. Indian time?
Yes.
So basically, we were studying electrochemistry. Have you studied it before? Yes or no? Any chapter that you have completed in of class 12? Okay, no problem. I'm waiting. Just reply me whenever you are available. Are you there now? Person, am I audible
Yes,
now?
sir. Can you hear me now?
Yes, yes. Now I can hear you. Wait a minute.
Yes.
Okay, let me know which chapter you have completed in chemistry. Any
So
chapter that you have
we just finished solutions.
solution you have finished. Okay, so
Yes.
this is in a school or in coaching?
School. We started from organic chemistry.
From organic chemistry. Okay, let me know. Is there any test in this month or the coming month, August?
Yes, sir. There's the exams next month.
Next month. What will be the syllabus?
Uh, 1 second. I'll just
Yes,
check
yes.
it.
Just let me all in this that are very important. Darshan, are you there?
Yes, sir.
I'm going to start electrochemistry, and I have already taught about electrolytic conduction and Corlot's law, molar conductivity, and all that. Now I'm going to start about electrochemical cell. Just try to understand. If you have any doubt or if you don't understand, just let me know. I will go from the basic.
Okay.
So this is basically electrochemical cell. Other students will join soon. Electrochemical cell. We also call it as galvanic cell. RIM
Yes, sir.
or voltaic cell? Okay, I was just checking. Voltaic cell. Then, do you have any doubt from the previous class?
No, sir, I don't.
So we just started a new topic, that is electrochemical cell and galvanic cell. What does this electrochemical cell do? Basically, it converts chemical energy into electrical energy. Electrical energy. And for your kind information, I already taught you about what is electrochemistry. Electrochemistry deals with the conversion of energy from chemical energy to electrical energy and electrical energy into chemical energy. So basically there were two types of cell. One is electrochemical cell and another is electrolytic cell. Electrolytic cell that converts electrical energy into chemical energy, and electrochemical cell is one that converts chemical energy into electrical energy. Is that clear to everyone?
Yes, sir.
Electrochemical energy, sorry, electrochemical cell is one which converts chemical energy into electrical energy. And also you need to note this process in electrochemical process, this is due to a spontaneous redox stage. A spontaneous redox stage. So Darshan, do you know what is a spontaneous process, a spontaneous reaction, or a spontaneity? Darshan, any one of you, Madiha, Rim, what is a spontaneity or a spontaneous? Am I audible to all of you? Am I audible to all of you?
Yes, sir.
So can you tell me what is a spontaneous and non-spontaneous? Please let me know. If you don't know, that's not a big deal. Explain it. I will again explain what is a spontaneous. A spontaneous reaction or a process is that process or that reaction which occurs on its own. We don't need to apply any external agent, like we don't need to give it, we don't need to give the process heat, temperature, pressure, and all that. That called spontaneous process, and we recognize that spontaneous by calculating delta G. This delta G is Gibbs free energy, and if Gibbs free energy is in negative, that means for a reaction, if Gibbs free energy is negative, that means it is a spontaneous reaction. Is that clear to everyone? Is that clear to everyone?
Yes, sir.
Yes, sir.
Example of galvanic cell or voltaic cell: nickel cadmium cell, nickel cadmium cell, zinc copper cell. Basically, zinc copper cell is also known as Daniel cell. That is the name of a scientist. Also, copper lead cell. So these are all examples of electrical cell. You can call it. Okay, please write it, and then I'm going to define. Everyone,
Done.
very good. Madiha, Reem, Darshan.
Done, sir.
Darshan, these are all example of cell, that is electrochemical cell. Okay, thank you. Yes, please respond me as soon as possible. You can speak, or if you are not able to speak, or if your mic is not working, then you can reply me in chat box. Now, I'm going to take example of Daniel cell. Daniel cell. This lecture is very important for now stick this. Now see, Daniel cell. I'm going to draw a representation of Daniel cell. This is a container, and this is basically an electrode that is made up of zinc rod. This is basically an electrode that is made up of zinc rod, and there is another container in which another electrode is there, and this is made up of copper rod. Copper rod, and this is joined by like this. Now see, there is a solution of ZnSO4 in this, and there is a solution of CuSO4 in this. That means this is a solution of ZnSO4, and there is a solution of copper sulfate, CuSO4. Now what happens here is this rod is basically, which is made up of zinc, will oxidize. That means Zn plus 2. Basically, this rod is made up of zinc, and zinc will break down and convert into Zn plus 2, releasing some electrons in this. And if it is electrons, you can see electron density on the left hand side is more now because of oxidation of zinc rod. So since its density or quantity is here more on the left hand side, so electron will start travel from left to right. That means left container to right container, and we know that the direction of current will be from right to left. Right to left. Is that clear, everyone? Just make it ampere.
Yes, sir.
So what I want to tell you is that this zinc rod will be initially it is a rod in solid state, but when you dip in zinc sulfate solution, this zinc rod will be break down and convert it into Zn plus 2, and electron density will be here more, and that's why electron will move from left and current will move from right to left. Now this is, since this is electron, this is basically anode, and that means negatively charged. That's why here it is negative and here it is positive. Now see what happens. You know that electron coming from left to right, and there is a solution of CuSO4. That means Cu plus 2 and SO4 minus 2 in this solution, because it is a solution of CuSO4. So electrons comes here, and Cu plus 2, which is positively charged. So Cu plus 2 will be attracted by these electrons, and it will go and stick to this rod. Okay, so what happens on the left hand side? Zinc is converting into Zn plus 2 by losing 2 electrons. And what happens here is Cu plus 2 gain 2 electrons from the rod and convert into solid Cu. Is that clear? This is positively charged. This is cathode. Are you getting my
Yes,
point?
sir. Yeah.
There will be oxidation on left hand side in electrochemical cell, and there will be reduction on the right hand side. Okay, so we can easily learn it through a mnemonic LONE. Always remember LONE. L stand for left, O stand for left, L stand for left, O stand for oxidation. That means whatever is on the left hand side, there will be oxidation, and on the left hand side there will be anode, and anode will be negatively charged. Anode will be negatively charged. Are you getting my point? This LONE is trick to remember Daniel cell. On the left hand side, oxidation will take place. It is anode. The electron is negative. So you can also remember the one which is on the right hand side with the help of left one. RR, you can write on the right hand side, there will be a reduction, and you know that this is cathode, and R are sick, and this is positively charged. This is positively charged. Let me know if you have any doubt on this topic. Also, there is a question I want to ask is that from where these two electrons, copper plus 2 is getting or gaining? From where these two electrons, copper is gaining from rod, and from rod. I already showed you the direction. Cu plus going to the rod, that means cathode, and gets electron or gains 2 electron. And from where this cathode is getting electron, then it is from anode. Anode have a lot of electrons. Here the potential will be higher density of electron, so it will go from left to right, and on the right hand side copper will gain and reduction takes place. Please write it. Now we will talk about electrode potential. Let me know when you are done with this. Are you able to understand it? Am I audible clearly?
Yes, sir.
Let me know whenever my voice breaks or my I'm lagging on. I'm waiting. Let me know when you are done with this.
Done, sir.
Very good.
Done, sir.
Very good. Thank you. Everyone done with this. Darshan, am I lagging now? Darshan, am I lagging?
No, sir.
Thank you. Now see, we are going to study electrode potential. Electrode potential. I just want to know, did I teach you in this in last classes that I just taught you? Rim,
Yes, sir. You taught me.
you should tell me. I just forgot. No problem. Electrode potential. See, I'm going to define what is electrode potential. This is a container in which aqueous solution of a salt is present, and this is electrode, and this is metal rod. This is metal rod, and here metal ions are there. Metal ions. You can consider with your on comfortability that this is made up of zinc. Now what happens? Metal, just take let metal oxidizes. There will be two cases only. One is metal oxidizes and another is metal reduced. So if metal will be oxidized, let's say metal is oxidized into plus n, that means it lost n electrons. So n electrons will be here. And now I'm going to define what is electrode potential. So basically the potential difference between electrode that is made up of metal rod, the potential difference between electrode, or you can call it metal rod, and its ions under equilibrium is called electrode potential. Under equilibrium is called electrode potential. And you can see oxidation taking place, and you can also call it oxidation potential. So basically, what is electrode potential or oxidation potential? The potential difference between metal rod and its ions, that is called electrode potential or oxidation potential. To be more specific, oxidation potential we will call it. Is that clear? M is converting into M plus N. We can write it like this. Please write it. Let me know when you are done with this.
Done, sir.
Done, everyone? Madiha, Darshan. Okay, Madiha, you are also done with this.
Yes, sir. Done.
Now see, I'm going to take an example, a reduction potential. Now there is a container in which a metal rod is there, metal rod and metal ions basically. These metal ions comes from salt like CuSO4, ZnSO4, PbCl2 and all that. Now what happens here is metal reduces. These both are connected to each other, just like the way we had in electrochemical cell. So one will be oxidized and another will be reduced. So what happens here? This is M plus N and it goes and stick to the metal rod. So it gains an electron and convert it into metal solid. This is in aqueous solution. Whenever metal is in ions, that means it is in aqueous solution. Whenever metal is in the metal in form of element, that means it is in solid state. So we can now also define potential PD, potential difference between metal rod, or you can call it electrode, metal rod and its ions in electrolyte under equilibrium. is called electrode potential, or we can call it a reduction potential. To be more specific, it will be a reduction potential. Electrode potential, that means it can be either reduction potential or oxidation potential. So what we call, basically when I say students, that means every gender comes in that. But to be more specific, boys as student, that means we are talking only about boys. So electrode, both are electrode potential, but depending upon the whether it is oxidizes or reduces, that is reduction potential and oxidation potential. Please write it. Let me know when you are done with this.
Done, sir.
Very good. Darshan and Madhiya.
Just a minute. Done, sir.
Darshan. Okay, thank you. Now see, write a point, write a topic first on which electrode potential depends. Factors on which electrode potential depends. So on which factor it depends? The first is basically nature of matter. Nature of matters and its ions. Nature of metal and its ion, it depends on nature of metal and its ions, because some metals oxidizes in this form Zn+2, and some metal like Fe can be oxidized into Fe+2, and Fe can also be oxidized in Fe+3. So depending on the metal in which state it is oxidizing, like +2, it is losing 2 electron, 3 electron, 5 electron, that depends, that is basically affect electrode potential according to their oxidation, how many electrons it gains or how many electrons it loses, that depends, or that affects electrode potential according to the ions or electron loses or gains. Please let me know with the or if you are done with this. Second, concentration of ions. Electrode potential also depends on concentration of ions. If concentration of ions will be more, it will affect electrode potential. If concentration of ions will be lesser, the electrode potential will be affected. So how much it will be affected and how basically it affected, we will study about this in Nernst equation. Please write it. And also write, in case of gas, we take partial pressure. In case of gas, we take partial pressure. Please write it. And the third, which is very important, electrode potential also affected by temperature, increasing temperature, decreasing temperature. So electrode potential depends on three factors: nature of metal and its ions, concentration of ions, and the third is temperature. Let me know when you are done with this. Everyone done with this? Darshan and Madiha,
Done, sir.
Darshan, very good. Now see, there is a standard condition that we need to learn. What is a standard condition? Like you have already studied STP in class 11, the standard temperature pressure, and what a standard condition here is. The first is condition is concentration. Concentration in a standard condition, concentration means one molarity. One molarity. The second condition, if it is gas, that means pressure in gas will be equal to, we will take 1 atm or 1 bar. That is fixed. And the third standard condition for temperature is that 298 Kelvin, or if you are going to convert it into degree centigrade, it will be 25 degrees centigrade. Please write this as standard condition. Are you done with this?
Done, sir.
Done. Darshan, you are also done. Now see, oxidation. That means electrons loses. So basically, M in elemental form will have oxidation state 0 and oxidizes into plus N. That means an electron loses. So we write or represent it as E M slash M plus N. That means it is going from M equals to 0 to plus N. And I'm going to write E naught here. E naught, this naught represent a standard. This naught represent a standard. If I'm writing E, that means electrode potential. That means electrode potential. But if I'm writing E naught, that means a standard electrode potential. A standard electrode potential. Is that clear, Madiha? So basically,
Yes, sir.
since you can see, wait a minute, my camera. You can see that here oxidation takes place, so it is oxidation potential. Oxidation potential. And if I'm going to write, this is oxidation potential, and if I'm going to write E naught M slash M plus N, that means a standard oxidation potential. A standard oxidation potential that we will write SOP and here OP, oxidation potential and a standard oxidation potential. Similarly, for reduction, you know that M plus N will gain an electron and will be converted into M. That means it has initially oxidation state plus N and now it is 0. It gains n electrons. So I'm going to write E, just erase this. E M plus N slash M is reduction potential RP. Reduction potential RP. And if I'm going to write E naught M plus N slash M, that means a standard reduction potential. A standard reduction potential. Please write. Very important it is. SRP. Let me have what. So whenever I do mute or remute, it happens. Let me know when you are done with this. Madhya, let me know when you are done with this.
Done, sir.
Darshini, you are also done with this. Now see, electrode potential is of two types. Electrode potential is of two types. The first one is oxidation potential and the second one is reduction potential. But when in the question, if it will be asked that calculate electrode potential, that means what we have to calculate? Oxidation, is it talking about oxidation potential? Is it about finding oxidation potential or reduction potential? So according to IUPAC, whenever we talk about electrode potential, that means we are going to calculate a reduction potential. Is that clear, everyone? Whenever it is about to find electrode potential, that means we need to calculate a reduction potential. Is that clear, everyone? Now see, this is electrode potential, and also if it is talking about a standard electrode potential, that means a standard reduction potential. So it is very easy to understand that reduction potential is equal to electrode potential, or a standard reduction potential is equal to a standard electrode potential. A standard electrode potential. Now you have to remember one thing, is that oxidation potential is numerically equal to a reduction potential. Numerically they are equal because the potential to lose electron will be equal to the potential to gain electron, but they are negative, they are opposite in charges. They are opposite in charges. That means if you have oxidation potential that will be -1 volt, that means reduction potential will be minus of -1 volt, that will be +1 volt. Charges will be different. If oxidation potential is +1, that means reduction potential of that will be -1. Are you getting my point? I just read it incorrectly. If oxidation potential is -1 volt, that means reduction potential will be +1 volt. Is that clear, Darshan and Madhya?
Yes, sir.
So I can write oxidation potential is minus of reduction potential. So a standard oxidation potential will be minus of a standard reduction potential. Also, oxidation potential will be minus of electrode potential, because electrode potential is equal to reduction potential. So a standard oxidation potential will be equal to minus of a standard electrode potential. Is that clear, everyone? In numerical, we have to be careful. If oxidation potential will be given, we need to convert it into reduction potential. Wait a minute. Let me know when you are done with this. Madhya, are you done with this?
Yes, sir.
Now see, we are going to find EMF of cell. EMF of cell. So I'm just going to draw a diagram. This is electrode that is negatively charged, and there is another electrode in this container, another container that is positively charged, and they are connected with a voltmeter like this. Now you know that this is anode, and always remember in this cell, anode is on left hand side and cathode is in right hand side, and oxidation takes place, and here a reduction takes place. How? M is converting into M plus N. We have done it so many times, and reduction is M plus N gains an electron to give M. So basically, how we are going to calculate EMF of cell, that means electrode potential of cell, will be equal to electrode potential of oxidation potential plus electrode potential of reduction, that is means RP. And we know that oxidation takes place at anode and reduction takes place at cathode. Please write up to this. This is very easy. But always remember, when we are going to numerical, we don't need to write the value of oxidation potential. We have to convert it into a reduction potential by the relation of oxidation potential is equal to minus reduction potential. Please write. Everyone done with this?
Done.
Yeah. Darshan, you are also done with this. Now see, I told you that we don't need to write EOP. EOP will be equal to minus of ERP. That means we need to convert this oxidation potential into reduction potential. If you are going to put the value in this form, it will be wrong. The answer will be wrong. Also, this is anode and this is also anode. We know that. Now, EMF of cell will be equal to E reduction potential of anode, that is in minus, plus E oxidation potential of cathode. Sorry, reduction potential of cathode. The reduction potential of cathode. This is very important to learn that E cell will be equal to ERP of cathode minus ERP of anode. And we can directly write E cell will be equal to E cathode minus E, but it is understood that already we know that anode is will be oxidation, but we have to put, but we value of reduction potential of that, and E cell will be also equal to, you know that in representation we keep the value of in representation cathode as an cathode is on the right hand side, so ER R for right hand side and anode is on left hand side, so EL. E right minus E left. R is for right, L is for left. And just be careful, both are reduction potential. We need to put the value of reduction potential for both. Madhya, are you there?
Yes, sir.
Is my screen visible?
Yes, sir, it is.
Okay, please write it and let me know when you're done with this. Let me know when you are done with this.
Done, sir.
Very good. Now see, we need to apply this formula. Also, if E cell is equal to E cathode minus E anode, and E cell we can also write E right minus E left. So we can also write E naught cell is equal to E naught cathode minus E naught anode. And E naught cell can also be written as E naught right minus E naught left. It is important to note that this naught is for a standard condition and the left one is not for a standard condition. Okay. Just let me know when you are done with this. Then I will give some
Done, sir.
formula. Okay. One more thing is that okay, P cell R for right. We are talking about a standard on the right hand side and non-standard on the left hand side. Now see. I'm going to give you a question. Wait a minute. And am I audible now?
Yes, sir.
Okay. I'm going to write a question. Please write with me. There is a representation of a cell Ni/Ni plus 2 double slash Ag plus slash Ag. Now it is given that E naught Ni plus 2 slash Ni is given as minus 0.25 volt, and it is also given that E naught Ag plus slash Ag is equal to 0.80 volt. Find E naught cell. That means we need to calculate a standard electrode potential of cell if this is given.
So, sir, is E naught Ni plus 2 slash Ni E naught R?
Is not. See how we are going
It
to
is
calculate.
the
See, Madhya, you know that from representation, left hand is anode. That means oxidation, yes or no? And right hand on right hand
yes.
side it is cathode. That means reduction. So first of all, you are going to write a formula. E naught cell is equal to E naught cathode minus E naught anode. But make sure you are going to take a reduction potential for both of them. Okay. Is that clear?
Okay.
This is cathode. Cathode on cathode, you can see Ag plus is given. Now check here that it is a reduction potential or oxidation potential. Then you can see plus is going into 0. So it is reduction potential and we need reduction potential and it is on cathode. So I'm going to put the value 0.80 minus. Now come to anode. On anode, Ni plus 2 is given and we need to take reduction potential of this. And how we are going to recognize whether reduction potential is given or oxidation potential is given? You can see it is going from plus 2 to 0. That means reduction potential is given. So directly write the value of this and just solve it. 0.80 plus 0.25, it will be 1.05 volt. Got it?
Yes, sir.
Okay, just write it. Let me know when you are done with this.
Done, sir.
Yes or no? Yes.
Yes, sir. Done.
I'm going to give you another question. That is basically zinc slash Zn plus 2, 1n, double slash Cu plus 2, 10 raised to the power minus 2n slash Cu. Now, it is also given that E naught Zn plus 2 slash Zn is equal to minus 0.76 volt. And it is also given that E naught Cu plus 2 slash Cu is equal to plus 0.34 volt is given. Calculate E naught cell.
Sir, can you directly use the values because it's given?
Madhya, are you there?
Yes, sir.
Okay, please do this. And if you have any doubt, please ask me.
Sir, I was asking if we can use the direct values of E naught Zn and E naught Cu.
Yes, yes.
Sir,
Let
is
me
the
know when
answer minus 0.42 volt?
minus 0.42. See, if you are going to solve it, E naught cell will be equal to E naught right minus E naught left. On the right hand side, it is Cu, that is cathode. Now see, this is reduction given, E naught right minus E naught left. Now see, the reduction is given, right hand side copper, so it is plus 0.3 volt minus, come to this Zn plus 2, because on the left hand side Zn is there and its also reduction potential is given, then minus 0.76, so it will be 0.34 plus 0.76, it will be 1.10 volt now.
Oh, yes, I took minus 0.74. So.
Please write. Let me know when you are done with this.
Done, sir.
Another question. Zn plus 2 double slash Pv plus 2 slash Pv. Now you can see it is given that E naught Zn slash Zn plus 2 is given as plus 0.76 volt and E naught Pv plus 2 slash Pv is equal to 0.13 volt is given. Calculate E naught step. Please do this first.
So is the answer 0.89 volt?
What is 0.89?
89 volt.
Just see. Did you check whether electrode oxidation potential is given or reduction potential is given?
Yeah,
You
I saw
didn't
it
check.
is oxidation potential is given.
No, see. Right is cathode and left is anode, right? Yes or no?
Yes.
E naught cell will have a value E naught cathode minus E naught anode. And you know that on cathode, PV plus 2 is given. PV plus 2 will be there. So before putting this value, you need to check plus 2 is going into 0. That means the reduction potential at cathode is given. That means 0.13 minus. Now at anode, you know that this will be, just don't put the value before checking this. It's going 0 from plus 2. That means this value is oxidation potential. But we need to write the reduction potential in numerical according to
Yes.
I. So the reduction potential will be minus of this. So it will be 0.76 minus 0.76 volt. So if you are going to put the value minus 0.76, you will get 0.13 plus 0.76. What will be the answer?
0.89. I told
Okay,
you.
make sure just write this, but practically it is in negative. So you will get the 0.63 volt, but positive. You got this?
Sir, I got 0.89 because like I didn't use minus 0.1.
0.89. That means you just added it. Please write it. Done.
Sir, why are we using minus 0.13 here?
Wait a minute. I'm not able to hear it. Please speak up.
I was asking why are we using 0.13 over here, minus 0.13.
Bio? Are you talking about lead? Can you message me in the chat box?
Sir, I can't send you the message. It's not getting sent.
Can you see the chat box?
that was by mistake. I wrote it 0.3 plus 0.3. That's why I just corrected
Okay, sir.
it. In question, I corrected it. That's why minus 0.13 I wrote. Now see, another topic, that is feasibility. That means a spontaneity of cell, or you can write the reaction with feasibility of cell reaction and gives free energy and gives free energy. Feasibility of cell reaction and gives free energy. Now see, there was a formula in class 11 in thermodynamics. Before that, we know that delta G, if delta G is less than 0, that means the process is spontaneous. If delta G is greater than 0, that means it is non-spontaneous. And if delta G equals to 0, that means the process or the equation reaction is in equilibrium. So please write it first. Then I will give you a formula from thermodynamics. Delta G will be equal to NF E naught cell. E naught cell, that means we are talking about a standard condition. N is number of electron transferred, number of electrons transferred. F is Faraday's constant. Faraday's constant, which has a value approximately equal to 96,500 coulomb. E naught cell is a standard electrode potential of cell. Standard electrode potential of cell. Please write.
Done, sir.
Done.
Yes.
Now see, the questions will be, you already know how to calculate E naught cell, and from the reaction or the representation you can easily calculate number of electron transferred. F is given, so all depends on calculating E naught cell, and after that you can see whether delta G is less than 0 or greater than 0. If it is less than 0, the cell will be feasible or spontaneous. If it is greater than 0, the cell will be non-spontaneous. So the first questions comes out to be, find the standard free energy, that means delta G naught. Also, since we are talking about, just correct it, since we are talking about a standard, so write delta G naught. Now the question is start. Find a standard free energy and predict feasibility of cell. Predict feasibility of cell, whether it will be feasible or not. It's also given that there is a representation Zn/Zn plus 2 double slash Cu plus 2 slash C, and E naught Zn plus 2 slash Zn will be equal to minus 0.76 volt, and it is also given that E naught Cu plus 2 slash Cu will be equal to plus 0.34 volt. Please put the value of E naught cell. After finding the value of E naught cell, put the value of E naught cell in delta G naught. You know the value of F E naught cell you will get from the formula. What about N? You are going to write a reaction from this representation. Then you will come to know how many number of electrons are gained or lost. Then put the value, you will get your answer. Let me know if you are not able to do it.
Sir, can you explain this question?
Yes, see, we need to calculate delta G naught. That has the formula minus NF E naught cell. Now we don't know what is N and what is E naught, and F we know because it's constant and it has a value 96,500 coulomb. So first of all, can you write the reaction of this as I have already taught you about it? Can you write? So if you are going to write a reaction, it will be Zn plus Cu plus 2 will give Zn plus 2 plus Cu. So you can see 0, 2 plus 2. That means N is equal to. Now what about E naught? E naught cell we can easily find out. That is E naught cathode minus E naught anode of reduction potential. E naught cathode. Cathode is this. Now cathode has a value reduction potential that is 0.3 volt minus E naught anode. Just check it. Yes, reduction potential. So it will be minus 0.76. So it is approximately plus 1.10 volt. Now going to put the value. Delta G will be equal to minus N. That means 2 into 96,500 into this is 1.10. Now you can see that this is negative, positive, positive. So delta G will be lesser than 0. That means cell is feasible. Cell is feasible. And also how much energy gives free energy? Just multiply it and write a joule. It will be in joule. It's so easy.
Okay, sir.
In the next class, we are going to study about Nernst equation. Are you done with this?
Sir, 1 minute.
Yes or no?
Sir, just a minute.
Okay.